Looking beautiful. MashaAllah, nice and clear. Okay, ladies, are we looking? Is everybody ready? Yeah? Put your marks on the side. Let's try to use different colour if we can, please, folks. Alright, okay, are we ready for another quick blast to try to finish these questions off? How many questions you got left now, Asmia? I've got up to 26, 14 questions, yeah?
Yeah.
So let's just try to quickly finish these 14 questions off. Here we go, question number 12. Question number 12 says, translate the triangle above by the vector 3 minus 2. Ramiz, check. Good, clear. 3 minus 2. What does 3 minus 2 mean? Translate the triangle by the vector 3 minus 2. The first 3 means along the x, which means 3 that way. The minus 2 means along the y, which because minus means down, rather than up and down. So we'll get this point here and go 1, 2, 3 for the first number, and then minus 2, 1, 2. Okay, now, what I've done here, the 3 and 2, you could do that for each corner. Okay, but I'm just going to do this quick way. Once I've got this corner, I can work out the next corner because there's 2 corners in front. Once I know this one here, I can get to that one by going 1, 2, 3. So I'm going to reconstruct the shape quickly. There's my shape. That question's done. Okay, so you only have to pick out one corner and move it across and then reconstruct the shape. Or if you want to do the long way, you move each point 3 and minus 2. Okay, that's lovely. Okay, next question. Right. The next question says, describe fully the single transformation that maps triangle A onto triangle B. Whatever you do, folks, do not use the word transformation in your answer. They're going to describe the transformation. So is it, for example, a reflection, a rotation, an enlargement, a translation? Yeah, you can't use the word transformation back in the answer. Now to get from here to here, it looks like we've turned it around. So the first one we're going to use here is rotation. Okay, now this was facing down, now it's facing up. What's the angle to that? What's the angle? 180. You've done that? Yeah. Rotation, 180 degrees. Now, when you do 180 degrees, Ramiz, do we need to say that it's called, do we need to say that? Not for 180, don't.
Oh, you could say
because it doesn't matter. But if you do, it won't make any difference. Okay? So rotation, 180 degrees. Okay, for those of you who put in, that's okay, but it won't be wrong. 180 degrees. Okay, and then we have, what else? We're going to find the center. Let's join them 2 corresponding points. Join them up with a line. Find 2 other corresponding points. Let's join them up. Now, where are those 2 crosses here? So we now know there is a rotation, it's 180 degrees about. Okay, what do we call the 0, 0 point? We can either call it 0, 0 or we can call it the origin. Okay, so them are the points that you need. Okay, if you were to put clockwise, anti-clockwise, that won't be wrong, but that's the key point. A mark, and a mark. 3 marks, done. That's question. What question was that? Question number 12, part B. Question number 13. Jenny filled some empty flower pots completely with compost. Diagram not accurately drawn. Each flower pot is in the shape of a cylinder of height 15 centimeters and radius 6 centimeters. She has a 15-liter bag of compost. So now they're talking here about volume, liters, and here we got centimeters. We've got 2 different units, but they are similar, and I'll show you how. Okay. Now, when we work out volume, for example, of the shape in centimeters cubed, 1 centimeter cubed is equal to how much in milliliters? Does anybody know?
1,000.
No, 1 centimeter cubed is equal to 1 milliliter. Okay, now 15 liters. How many milliliters are there in 15 liters? That's 1 milliliter. Now, how do you go from 1 milliliter to 1 liter?
1,000.
Time by? Okay, so 1,000 centimeters cubed is equal to 1 liter. That's our conversion between this unit here, we're going to get volume, and the unit given us in the question.
Why is it centimetre cubed?
Because it's volume, centimeters times by centimeters times by centimeters cubed. So if you were to have one little baby centimeter cubed in volume, that would have the same amount of liquid as 1 milliliter. So that's how these units here connect with this unit. They're talking about liters here and centimeters, two different things. This is how they're connected. So 1 centimeter cubed from here is worth 1 milliliter from here. Okay, let's have a look at now. She has 15 liter bag. Okay, let's work out the volume of this first, yeah? Okay, how do you work out the volume of this? Put out the formula for me. Volume of this cylinder is equal to the area of the face times by the height. So volume is equal to area, we say face or cross section, whichever one you like to use. Multiply in this case by the height. That is the general formula for the volume of this question. Now let's make it specific. Now what is the area of this circular top part here, Umar?
Pi r squared times.
Pi r squared is the first part, yeah? And then multiply by the height we just call it h for the moment. Let's put some values in there now. So pi we can use 3.14 times by the radius. What's the radius? 6. Times by 6 squared. What's the height? 15. Okay, so we need to do that calculation. I'm going to do it as well now. So 3.14 times by 6 squared times by 15. What do we get? So what is our volume in? Okay, our volume is 1695.6 centimeters cubed. We have a 15 liter bag, and let's change 15 liters to centimeters cubed. So 15 liters. Okay, if we change, we said each liter is 1000 centimeters cubed. So that's our conversion. What's 15 times by 1000? 15,000. So in 15 liter bag, we have 15,000 centimeters cubed worth of volume of this compost. Now we know that one of these pots has how much volume? That much, yeah? And we know the big bag that she's bought has that much volume. What do we do these two numbers? We
divide.
So the volume of the bag, the compost bag. We want to see how many of these fit into this. Divide. So we now do 15,000 divided by 1695.6. 15,000 divided by the answer. Okay. And what do we get? She fills up each flower pot completely. How many flower pots can she fill completely?
8.
So she hasn't got enough for the 9th one, so she can only fill up 8 completely. Okay, put your hands up if you got that question right at home. Okay, Ramiz, you get that right at home?
Which one?
This one here. Who got that right? 8.
I got that one.
Yeah? Okay, right. Question number 14. Pick some voice from that. Okay. Question number 14. A ladder is 6 meters long. The ladder is placed on a horizontal ground resting along a vertical wall. The instruction for use, the ladder says the bottom of the ladder must not be closer than 1.5 meters from the bottom of the wall, how far up? So this distance here should be 1.5 meters. 6 meters is the length of the ladder. And the question is saying here, how far up the wall can the ladder reach? So what do they want us to work out? They want us to work out this height. Now, what kind of triangle do we have here? This is called a right angle triangle. Right angle triangle, what technique can we use? Pythagoras theorem. So we say a squared is equal to b squared plus c squared. That's one version of the formula. I always like to rewrite it. Hypotenuse squared is equal to b squared plus c squared. That's for me to be more specific, that the a value is always going to be the hypotenuse. So what is the hypotenuse here? What is it? 6. Okay, now b and c, I can arbitrarily label that's b and call that c. It doesn't matter which way you label them. So 6 squared is equal to b squared is equal to?
Is it minus?
That's why we left minus there. Means is it all in? Am I all in? Yeah. Now we've got to work out the value of c, which is the height. So the opposite of adding 1.5 squared is? So 6 squared minus 1.5 squared is equal to c squared. I don't want c squared, I want c. So the opposite of squaring is?
Square root.
Take the square over and square root. So we can say c is equal to the opposite right over here actually. We have space 6 squared minus. Right, let's have a look. So you press the square root button first. 6 squared take away 1.5 squared equals, okay, press the SD button. What do we get, folks?
5.8094756119. So 5.8.
Okay, we've got to give it to one decimal place. One decimal place means we've got to stop here. The next number is 0, so we leave it alone. So 5.8 meters is the height that you can reach. Okay, you got that already? Question number next, what's the next one?
50.
Question number 15. In a sale, normal prices are reduced by 20%. The sale price of a coat is £52. Work out the normal price of the coat. This is called a reverse percentage question. Okay. Are we done? Try that question. Yeah. Ramesh done it. Come on. So what's the original price of the coat? The original price of the coat is 100% value, yeah? And then how much is it reduced by?
20%.
So how much is left over?
80%.
So 80% is equal to what? The sale price, which is £52. You want to go from 80% back up to 100%. So if I want to go from 80% to 100%, how do you go from 80 to 100? What we could do, looking at some kind of technique, we can go from 80% down to, we divide it by 8. That will give you how much percent? 10%. And then we can times it by 10 as an idea. So I want to get from 8, I know 80, I want to get to 100. So we work out 10 and then times by 10. So work out 10% and then which is by divided by 8 and then times by 10. So what we do on the left hand side, we must do on the, so 52 divided by 8 times by 10. 52, about 8. That gives us what?
65.
So the original price of the quote was
65.
65. Lovely. Are we happy with that reverse question? If you got it right, give yourself a tick. If you haven't got it right, fill it in. Question number 16. Work out the length of BC. What kind of question is this, folks? This is a right angle triangle, so we're going to be using what? Sokotoa. So opposite, first one, opposite the angle is called the?
Opposite.
Okay, opposite the right angle is called the? And the leftover side has to be the? Adjacent. Now, we need to work out, it says they work out the length of BC. We need to work out this length here. So we're going to work out the O. Now, we got to work out the O and we know the A. So what sounds that make? O, A, over. So if you're doing over, that's going to involve which one?
Tower.
Tower. Over. Over's here. Okay. Okay, now, what do we know in this question? We know the
Opposite.
angle. And we know the adjacent. And we want to work out the opposite. So we, as we said before, you get your thumb and you cover it up with the opposite. So you cover the opposite of what you're trying to work out. I tell you the tan of the angle times by the adjacent will give you the opposite. So use the thumb technique on there. I'm going to draw the thumb on here now. So we know that the opposite is equal to the tan of the angle multiplied by the adjacent. Now the opposite, which is the BC, tan, what's the angle? Times by the A value, which is 8.7. So on the calculator, we press just the normal tan button, 36, now close the bracket off, then times it by 8.7. That gives us an answer of, what's that give answer? 6.32. And we want it to 100 decimal places, 632. Okay, the answer says 3 significant figures. So my first significant figure is where it means? What number? 6.
6.
First, second, third. That's my third significant figure. So that's my last digit. That's my decider. If it's less than 5, you leave it alone and you stop there. So the answer should be 6.32. That's okay? Got that one right? Good. Okay, if you got it right, mark it as right. If you haven't, fill it in. At least you know what it should be, and then you can. Okay, right, let's have a look. Okay.